Hello, my name is Ray. I'm the Ray in the Ray Code. In this video, I'll be covering the abstract factory design pattern. I'll be using C++. I have put timestamps in the margin so you may navigate to the section you desire most. My favorite is the SWOT analysis. I use other programming languages to cover this design pattern. I have used this programming language to cover all the design patterns that were given by the Game 4. Please like this video, leave a comment, and subscribe. You can find me on other social media platforms. Please search them out and become a Ray Code groupie. Share this video with others. Be good. Here are some reasons why studying the abstract factory design pattern can be beneficial for the C++ developer. Code maintenance simplifies system maintenance by isolating concrete classes and reducing dependency among objects. System scalability facilitates adding new families of products without altering existing code, enhances scalability. Interchangeability allows for the easy swap of product families within an application, promoting flexible software environments. Consistency ensures a constant set of products by enforcing relationships and dependencies between different objects. Product variation supports the production of various product versions without complicating the client code, keeping implementation clean. Integration ease helps integrate new product classes seamlessly into existing systems, reducing integration issues. C++ efficiency encourages efficient usage of resources in C++ by managing object creation and representation logic centrally. Abstract factory declares an interface for operations that create abstract product objects. Concrete factory implements the operation to create concrete product objects. Abstract product declares an interface for a type of product object. Concrete product defines a product object to be created by the corresponding concrete factory. Client uses only interfaces declared by abstract factory and abstract product classes. In this presentation, I plan to give an example of the abstract factory design pattern. I'll be using C++. We first will create an abstract factory returning types of dogs and types of cats, both domestic and wild. We will start with creating an animals class, which will be our parent class. We have a deconstructor, give it a sound method, and a getName method. These methods will need to be defined in those classes that will inherit from this class or interface. We create a subclass to animal we call dogs for a variety of dogs. And we create a cat interface for various types of cats. And we create a poodle class, which is a subclass of dog, or it is a type of dog, which is a type of animal. Since the poodle is an animal, it will need to have a make sound method. We also have the getName method that will be required for each animal. For this class, we will call it a poodle. We create a hyena, which is a type of dog. A hyena laughs, so we return a laugh. And we return the name. Let's create a domestic cat class, which is a type of class, which is an animal. Return meow, I am a domestic cat. And return the name domestic cat. Next, we create a lion class, which is a type of cat. And a lion roars. We return the name. Let's create an animal factory. The animal factory returns dogs and cats. And we do some cleanup. Now we create a collie class, which is a type of dog. We return a message and the type of dog name. Let's create a shepherd class, which is a type of dog. The shepherd returns wolf. And for get name, we return shepherd. For a type of cat, we create a tiger. A tiger gives out a roar. And for get name, we return tiger. Now, let's create a cheetah class, which is a type of cat, which is a type of animal. The sound a cheetah makes, roar. I'm a cheetah. For the return name, we return cheetah. The next animal I want to create is a wolf, and return the name wolf. Next, we create a fox, which is a type of dog, which is a type of animal. We return for sound will be laugh. I'm a fox. For get name, we return fox. Now let's create a domestic animal factory for our poodle, collie, shepherd, and domestic cats. We start with a dog class, which will return a poodle. We can modify this for different types of dogs if we like. We can create a create cat method to return a random type of domestic cat. Now let's create a wild animal factory, which is a type of animal factory. From here, we'll be able to return hyenas, wolves, foxes, or lions. Let's use the dog class to return hyenas. We can use the cat class to return a lion. Now, let's go over to the main and create a demo for our project. At the top, we will include the H files that we need: domestic animal factory, wild animal factory. We will also need to include memory. Let's create a domestic animal factory that we can create a unique pointer for a dog and a cat. Now let's interact with these animals by having them make a sound with a get name. Let's also create a wild animal factory. So we can create a wild dog and a wild cat for my wild animal factory. Let's make a sound and get name these animals. Howl and run. Wolf. I'm a cat. Laugh. I'm a hyena. Ray. I hope you have a nice day. This is a SWOT analysis of the abstract factory design pattern using C++. S. Strengths. Abstraction. The abstract factory pattern provides a high level of abstraction. It decouples the client code from the concrete classes it needs to instantiate, promoting loose coupling and flexibility. Consistency. Features that related objects are created together, maintaining consistency across the product families. Scalability. It is easy to introduce new variants of products without changing the client code, making the system scalable and adaptable to future requirements. Flexibility supports switching between different families of products easily, enabling a flexible and extensible architecture. W. Weaknesses. Complexity. The pattern introduces additional complexity in the code base. Implementing an abstract factory requires creating multiple interfaces and concrete classes, which can increase the code's complexity. Maintenance. The number of classes and interfaces can grow significantly, making the system harder to maintain and understand. Learning curve. Developers need to have a good understanding of the pattern to implement and maintain it correctly, which can be challenging for those new to design patterns in C++. O. Opportunities. Modern C++ features. Utilizing modern C++ features like smart pointers, types, traits, and templates can enhance the implementation of the abstract factory pattern, making it more efficiently and easier to use. Cross-platform development. The pattern can be beneficial in cross-platform development, allowing different product families to create for different platforms with minimal code changes. Integration with other patterns. Abstract Factory can be integrated with other design patterns such as Singleton, Builder, and Prototype to solve more complex design problems and create more robust systems. T. Threats. Over-engineering. There's a risk of over-engineering, especially for simple systems, where the benefits of abstract factory pattern do not justify its complexity. Performance overhead. The pattern might introduce some performance overhead due to its extra layers of abstraction, which can be a concern in performance-critical applications. Misuse. Incorrect use or misunderstanding of the pattern can lead to rigid and convoluted codebase, negating the benefits and making the system harder to work with. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment, and if you find me on the social media platforms, leave a comment there. Tell a friend the red code is awesome.